Welcome to Fascinating Facts. Come sit with me for a moment, look up at the night sky. In that vast dark expanse, countless wonders and terrors coexist. We see the gentle twinkle of distant stars, but we also know that lurking in the shadows are some of the most extreme objects the cosmos has ever forged. Today, we're venturing into one of the most mind-bending questions in astrophysics. Can a black hole actually destroy the universe? It's a question that feels like it's pulled straight from science fiction. A cosmic horror story of ultimate annihilation. These cosmic monsters are known for their extreme gravity and mysterious behavior, but are they dangerous enough to unravel reality itself? We imagine them as cosmic vacuum cleaners, relentlessly consuming everything in their path. Their reputation precedes them. They are points of no return, where the laws of physics as we know them break down into a singularity. The idea that one of these could grow unchecked, swallowing galaxy after galaxy until nothing is left, is a truly terrifying thought. But is it a thought grounded in cosmic reality, or is it just our human fears projected onto the grandest of scales? The universe is a big place, almost incomprehensibly so. To destroy it would require a force of unimaginable power and reach. Are black holes the ultimate villains of our cosmic story, or are they something else entirely? Perhaps they are not destroyers, but creators, sculptors, or simply a natural and necessary part of the cosmic ecosystem. To find the truth, we must journey together, guided by the light of evidence and reason. Let's break it down through 10 captivating facts. Before we can contemplate universal destruction, we must first understand the nature of our supposed culprit. So what is a black hole? Imagine a star, many times more massive than our own sun, living out its life for millions of years. At the end of its life, it runs out of fuel. The outward push of nuclear fusion that held it up against its own immense gravity ceases. And in that moment, gravity, the relentless sculptor of the cosmos, wins. The star's core collapses in on itself with such catastrophic force that it crushes down into an infinitely dense point, a singularity. This is the birth of a black hole. What makes it so formidable is the gravitational field it creates. It's so intense that it warps the very fabric of space-time around it, creating a deep well from which nothing, not even light, the fastest thing in the universe, can escape. This boundary of no return is called the event horizon. Crossing it is a one-way trip. This is why they seem so destructive, like cosmic sinkholes in the fabric of reality. But is this local ferocity a true threat to the entire cosmic ocean? Or is it more like a powerful whirlpool in a vast, unending sea? The scale of the universe is the key to this question. Here's a common misconception that fuels our cosmic anxiety. The idea that black holes are like cosmic vacuum cleaners, actively sucking in everything around them. This isn't quite right. A black hole's gravity, while immense, still plays by the same rules as any other object in the universe. Its pull is powerful, yes, but it weakens with distance, just like the gravity of a star or a planet. If you were to magically replace our sun with a black hole of the exact same mass, you know what would happen to Earth? Absolutely nothing. We would continue to orbit it just as we do now, though it would get very, very cold. The danger of a black hole is a matter of proximity. You have to get incredibly close to one to be caught in its inescapable grip. From a safe distance, it's just another massive object exerting a predictable gravitational influence. The universe is defined by its vast, empty spaces. The distances between stars and galaxies are so enormous that the chances of a wandering black hole getting close enough to swallow another star system, let alone an entire galaxy, are infinitesimally small. Their influence, as mighty as it is fundamentally local. They are neighborhood bullies, not universal tyrants. You might think, okay, a small black hole isn't a threat, but what about the really big ones? And you'd be right to ask. We know for a fact that monstrously large black holes exist. We call them supermassive black holes, and they are millions, sometimes billions of times the mass of our sun. And here's the kicker, we believe one of these giants sits at the heart of nearly every large galaxy, including our own Milky Way. We have one in our backyard, cosmically speaking. It's called Sagittarius A*, and it's about 26,000 light-years away from us. And yet here we are. Our galaxy is not being devoured. The stars are not all spiraling to their doom. In fact, these galactic centers are relatively stable places. The supermassive black hole acts as a gravitational anchor, a central point around which the galaxy elegantly rotates. It's an integral part of the galactic structure, not a force of chaotic destruction. The existence of these behemoths all across the observable universe for billions of years is perhaps the strongest evidence we have that black holes are not destined to consume everything. They are a feature of the cosmos, not a bug that will crash the system. Let's get up close and personal with a black hole's destructive power. Imagine an unlucky astronaut, let's call her Stella, drifting too close to the event horizon. What happens to her isn't a simple gulp. The black hole's gravity is so extreme that the pull on her feet, which are just a bit closer to the singularity, is exponentially stronger than the pull on her head. This difference in gravitational force, known as a tidal force, would begin to stretch her body. It would stretch and stretch, pulling her apart atom by atom into a long, thin stream of matter. This gruesome process has a wonderfully whimsical name, spaghettification. It's the ultimate demonstration of a black hole's localized power to tear matter apart. But notice the key word there, localized. This is what happens at the black hole. It's a terrifying fate for any object that strays too close, be it an astronaut, a planet, or a star. However, this process doesn't project force across the universe. It's a close-quarters phenomenon. Spaghettifying a star doesn't destabilize a galaxy, let alone threaten the fabric of the universe itself. It's a cosmic spectacle, but a contained one. Black holes are not always solitary wanderers. Sometimes they find each other. When two black holes are locked in a cosmic dance, they orbit one another, getting closer and closer, spiraling inward. As they do, they violently churn the fabric of space-time, sending out ripples across the universe. These are gravitational waves, the very echoes of space-time itself ringing like a bell. We've detected these waves here on Earth, confirming one of Einstein's most profound predictions. It's a testament to the awesome power of these cosmic events. Eventually, these two black holes will merge, combining their masses to form a single larger black hole, so they can grow. You might wonder if this process could continue indefinitely, with black holes merging and merging until one super black hole consumes everything. But again, we must bow to the tyranny of distance. The universe is expanding, and it's expanding at an accelerating rate. Galaxies are, on the whole, moving farther apart from one another. This makes it increasingly unlikely for black holes from different galaxies to ever meet. Their growth is limited by the amount of matter and the number of other black holes in their immediate vicinity. Let's indulge in a little science fiction for a moment. Could a black hole trigger a chain reaction of cosmic destruction? The idea goes something like this. A rogue black hole, perhaps ejected from its home galaxy, hurtles through space. It collides with a star, creating a new, slightly larger black hole. This new black hole then collides with another star and so on, creating a cascade of black hole formation that spreads like a virus. It's a terrifying concept, a runaway process that could theoretically convert all the matter in the universe into black holes. However, the physics just doesn't support this. When a black hole collides with a star, the most likely outcome isn't the neat creation of a new single black hole. It's a messy, chaotic event. Much of the star's material would be flung out into space at incredible speeds not captured. Furthermore, the energy released in such a collision would be immense, likely pushing other nearby stars away rather than pulling them in for the next stage of the chain reaction. The universe, it seems, has built-in safety mechanisms against this kind of runaway consumption. The beautiful chaos of astrophysics prevents such an orderly, destructive cascade. Not all black holes may have come from dying stars. There's actually a theoretical type of black hole that could have formed in the very first moments after the Big Bang. In that incredibly hot, dense, and turbulent early universe, some regions might have become so dense that they collapsed directly into black holes without ever having been a star. These are called primordial black holes. If they exist, they could range in size from microscopic, with the mass of an asteroid, to many thousands of times the mass of our sun. So, could these be the universe's hidden destroyers, like cosmic time bombs just waiting to go off? It's an intriguing idea, and some scientists have even proposed that they could be a candidate for the mysterious dark matter that holds galaxies together. However, And this is a crucial point, we have absolutely no direct evidence that primordial black holes exist. We've searched for them through various means, like looking for the gravitational lensing of distant starlight, and have so far come up empty. For now, they remain fascinating but purely hypothetical objects. A threat that may not even exist really cannot be the destroyer of our universe. We tend to think of black holes as eternal prisons, objects that only take and never give. But one of the most brilliant minds of our time, Stephen Hawking, showed us that this isn't entirely true. By combining quantum mechanics, the physics of the very small, with general relativity, he discovered something remarkable. At the edge of a black hole's event horizon, the quantum world is a bubbling foam of virtual particles that pop into and out of existence. Occasionally, a pair of these particles can be separated by the event horizon. One falls in, while the other escapes. This escaping particle carries away a tiny amount of the black hole's mass and energy. This trickle of escaping energy is known as Hawking radiation. It means that black holes are not truly black, they glow with a faint heat. And more importantly, it means they can evaporate. For a stellar mass or supermassive black hole, this process is unimaginably slow, taking longer than the current age of the universe. But it tells us something profound. Black holes are not eternal, they have a lifespan. They are not permanent fixtures, but transient objects on a cosmic timescale. They will eventually fade away. If a black hole isn't going to destroy the universe, what could? Well, astrophysicists have other, more likely candidates for the ultimate end. One of the most dramatic is a scenario called the Big Rip. This idea stems from the discovery that the expansion of the universe is accelerating, driven by a mysterious force we've labeled dark energy. In the Big Rip hypothesis, this expansion becomes so powerful and so fast that it eventually overcomes all other forces, including gravity. In the final moments of a Big Rip, the expansion would become so violent that it would first tear apart galaxies, then star systems. It would rip planets from their stars, and then, in the final fraction of a second, it would overcome the forces holding atoms together, tearing apart the very fabric of matter itself. Compared to this, the threat from black holes seems almost quaint. In this scenario, even black holes themselves would be torn asunder. So, the true potential destroyer of the universe isn't a localized object that consumes matter, but a universal force that pushes everything apart. So, we've journeyed to the event, horizon and back. We've seen that while black holes are objects of incredible power and mystery, they are not the universe killers of our nightmares. Their influence is local. They are a stable part of galactic structure, they are not eternal, and other cosmic forces pose a far greater, more fundamental threat to existence. Instead of seeing them as terrors, perhaps we should see them for what they truly are, invaluable tools for understanding the cosmos. Black holes are cosmic laboratories where the laws of physics are pushed to their absolute limits. By studying them, we test the boundaries of Einstein's theory of general relativity. The gravitational waves from their mergers give us a new way to see the universe. They are the source of some of the most energetic events we've ever witnessed, like quasars, which can outshine their entire host galaxies. They challenge our understanding of space, time, and information. They are not the end of the story. They are the key to unlocking the next chapter in our cosmic journey of discovery. In the end, the story of black holes is not one of destruction, but of perspective. They teach us about the awesome power of gravity, but also about the immense scale of the universe that contains them. They are not rogue monsters set to devour reality, but fundamental components of the cosmic web, as natural and necessary as the stars they were born from. The universe is far more resilient and far stranger than our fears might lead us to believe. The real story is always more complex, more nuanced, and ultimately more beautiful than the simple tale of a monster in the dark. Our journey through these 10 facts shows us that knowledge is the light we use to navigate that darkness. By asking these big questions, by challenging our assumptions, we replace fear with understanding and wonder. The cosmos doesn't present us with villains, it presents us with puzzles, and the reward for solving them is a deeper, more profound connection to the universe we are a part of. So keep asking, keep exploring. Follow fascinating facts, like, share and comment below to stay connected and grow every day with knowledge as vast and mysterious as the universe itself. Let your mind wander across the galaxies, ponder the mysteries of space-time, the birth of stars, and the fate of all things. The quest for knowledge is the greatest adventure we have. Thanks for watching. And remember, curiosity has no event horizon.